Hey everyone, how's everyone doing? Good? Like Justin said, I'm Dries, I work for Laravel. I do most of the open source stuff. I'm basically the asshole closing down your issue. Uh, oh wait, I can't say that? Okay, let's try it again. Hey, I'm Dries, I'm the super nice guy helping you out. Um, so I thought I was gonna wear this shirt and would be pretty unique today, but like have the audience is wearing it. But I'm like the only person obligated to wear it, so I guess it's fine. Um, okay, so we have a lot to cover, and I only have 30 minutes, so let's get going. Today we will be talking about event sourcing. And what I mostly want to achieve with this talk today, like there's tons of theoretical stuff out there yet. What I want to achieve with this talk today is like show you a really pragmatic way to introduce event sourcing in a Laravel app. Like there's tons of code in this talk, there's almost no theory. So if you don't know what event sourcing is, I recommend that the talks is going to be recorded, that afterwards you might like revisit it again to see how it's actually implemented. But it's mostly going to be code samples. We'll be using EventSauce. For the people who don't know what it is, it's a library made by Frank de Jonge, who you probably know from Fly System. And just like a really easy way to get started with event sourcing in a PHP application. It's really focused on queuing and how storage is done, and also has some really cool testing tooling in mind. What we'll be using in this talk is our main domain and process will be GitHub, and our process will be like a pull request. And for people who don't know what a domain or process is, domain, think of anything that your app is actually about. Like if you're GitHub, your domain is like open source repositories, source code sharing, and the process is a GitHub pull request. Funny thing about the slide is I'm using Font Awesome here for the icons. Screw you, Steve. I am using Font Awesome. Yeah. So for people with eagle eyes, this isn't really the icon for pull request. It's actually the branching icon. But because the pull request icon came with the Pro, the paid feature, I just used like CSS transform to rotate it and flip it, and basically it looks the same. That's how cheap I am. Anyways. Just to clear up some confusion up front, like I'm going to use the words model and command a lot, and they're not the same thing as an eloquent model and a console command. Think of model in this way as like the structure of your code in your application, the way how you model your software. And commands here are basically, you can refer to them as Q jobs, which you already know. So, there's like 4 different questions I want to answer in this talk, but because I mostly have time to answer one of them, we're going to go really quickly over the first 3 to like give you a little bit of a hint about what event sourcing actually is, and we can go immediately to the part of how we're going to implement it. So, what is event sourcing? I know like a lot of people might think it's like this magical thing that will solve all of your problems. And it does in some sort of way, but it brings along a lot of like constraints, like difficulty implementing it. But you get a lot of back from it. And just to like get immediately started out with some code, so you can get a grasp of what it's about. When you like working in a traditional way, you might in a Laravel app, you might like use an eloquent model to do some really CRUD-like operations, like create a new record in the database, update it, overwrite the existing data that was in there, delete the existing data. And how event sourcing really tackles this is it makes use of events which you already know in Laravel maybe, perhaps, and stacks those upon each other and derives the states from those events in the read models. I know this might sound like a little bit like a lot right now and abstract, but we're going to get into how it's done in a bit. What's the best takeaway you need to get from this talk, from this slide, is that instead of like using CRUD-like operations, you emit events and you save those in the storage. And that was for the writing side of operations. And for read sides, we're also doing like a little bit of a different thing. So for a pull request, you might need like the pull request itself, you need its author, you need the comments to display beneath it. So you need like 3 tables in your database to do some joins and get the data and display it to the front end. And in event sourcing, what you're instead doing, instead of like doing the traditional relationship thing, you're optimizing your read site for its specific use cases. So in this case, you might have like a specific table for the pull request view, which you're viewing, and just insert one record with all the data you need to display that data. So your reads become super fast and super simple in the end. Again, like this might be a little bit abstract, but we'll get to more details in a bit. So like I said, like your reads become easier because of this, because you're optimizing for your read site. Your writes become a little bit harder, trade-offs. I think it was Frank de Jonge who said that event sourcing makes the easy thing hard, but makes the hard thing easy. Trade-offs again. But there's a lot to be said for both techniques. Something you really need to know about event sourcing is that history cannot change no matter what. Because you're stacking events, and you're actually saving that historical state, and you're deriving state from those events, it cannot change. Because changing history can be done. You can travel back in time. Not yet, at least. So make sure you don't change history, because the event source police will come and find you. So you might ask yourself, like, why? Why would you use event sourcing? Why would you need it, actually? And there's like a couple of things. Like I said, like I don't have much time right now to get into this specific part, but just to give you like a really heads up about some of the benefits you get. Like I said, like your read sites, your read models become really fast. You're optimizing for your read sites. You can predict the future, basically. Like, imagine that you're like in a state, or very early state of your application, that you still don't really know what you're going to do with all of the data you're collecting later on. You can introduce event sourcing, save all of the state you ever gotten, and instead of overriding it, you have like a nice history log of that whatever happened. If your boss at one point walks in and says like, I want to report about this specific process, whatever has happened in the past, you can basically do it because you have all the data you need to make that report. You can travel back in time, and this is really cool if you're using something like Git, and you want to like display the state of your application in the past. At a certain point, you can roll back all of the data and display the application in exactly the state it was at a certain pinpointed moment in time. Together with Git, this makes it like a really cool feature. For auditing, if you're audited and people want to know like why something has happened at a certain point in time, you can really show them, okay, it happened because of these and these and these events. It's really cool stuff. So let's get to the actual part where we came for. So like I said, there's going to be a lot of code here. I'm going to go through it fairly quickly. The talk is being recorded, so if you ever need to be reflect on that, you can watch the talk again. First, let's start off with like the traditional way how you might handle a new pull request. So you might have a store method on your controller, and you might want to add a pull request to a user who's making the pull request. You take like a title, a description, an origin branch, the target branch where you want to merge it against, and you redirect back to a view. In event sourcing, this works a little bit differently. So what we're first doing is we're going to validate whatever it is you want to do against a certain set of business rules. We'll come back to that later. What we're going to use is like commands, queue jobs in this particular example, and we're going to use that to call some classes later on to emit those events. So we have a queue job here. We're using dispatch now because we want to do it in a synchronous way. We want to do it now, so it happens now. And we first generate a UUID up front, so we can use that in the redirect to immediately redirect to the correct view. When you look at that command, you'll notice a couple of things. Fair warning, I'm using a lot of type hints and a lot of final in this talk. I really hope Taylor doesn't fire me for that, but I think it'll be fine. So in the handle method of that queue job or command, you use like an aggregate route repository to retrieve an aggregate, a class that guards your business rules, and perform the command against that. This is probably the part of the talk where you're like, wait, what? The aggro what? So what aggregates and aggregate routes really are is they're more of a term like coming from the DDD community. They're not eloquent models. People tend to confuse them with eloquent models. Think of like eloquent models like representing the state in your database as is, like just represent a certain record in your database and represent state from that persistent storage. Aggregate routes are simple PHP classes. And what they do is they guard whatever it is you're trying to do in your process. So they will take the command you're feeding them. They will say like, okay, this command needs to be validated against this, this, and this. And then when this is, all of that is correct, they'll emit events which you can save in your storage and derive data from. We'll look at like everything of that in a bit. Aggregate routes can exist of multiple aggregates. If you want a quick example of that, think of like an aggregate route like a pull request, and like comments being small aggregates within that pull request, which have their own set of business rules. So the aggregate route is basically, like says, a class. In EventSauce, you need to implement an interface, implement a trait which adds new behavior. We'll dive deeper into the trait a little bit later. And this is basically how you get started with an aggregate route. How to handle the command is, like I said, like you probably have like a method on the aggregate route taking that command, and you use the data from the command to emit an event. So what we're doing here is we're creating a new event. Pull request was opened. We're passing all the data from the command to the event and recording that event against the aggregate route. We'll dive into the method a little bit later on. But you'll notice that first says you need to validate some business rules. So how you do that is you basically write some code to validate that certain scenarios can't happen, because that's important to you. Those are important to your business, to your stakeholders, that these things can't happen. And in this particular example, we want to make sure that the origin branch and the target branch aren't the same, because that just doesn't make sense, merging the same thing in the same branch. We throw an exception here, so the process stops, and you can react to the exception and inform your user that this is a scenario that can't happen. Something that's really cool, and something my buddy Freek actually told me, is that you can also record the unhappy path. So you're not like tied down to recording only events about the good things that happen in your process. You're also allowed to record things that are bad. So in this particular example, like if you want to merge a pull request, but it isn't approved first, then you can say like, okay, we're gonna record an unapproved merge was attempted, and we're going to throw the exception afterwards. And then you can like later on say like, okay, like how many pull requests were attempted that weren't like approved first. Pretty cool. So recording an event, like I said, this is the aggregate route behavior trait which we applied to the aggregate before. So what it does internally, it applies the event first and then adds the recorded event to its list. We're gonna use that list later on to save the events in the persistent storage. We'll get back to that later. How we can apply events is internally it uses a method to get the event, get the class from the event, and then use a method apply and then the event name against the aggregate. So why this is done is that first in the first part where you execute your command, you're only guarding your business rules. It's a separate piece of your aggregate where you guard against every scenario that can't happen. And after that, after you've added the event, recorded it, you can apply it against a pull request. So in this case, you're like adding the user ID, origin, the target to the aggregate route. So you can reuse that data later on when you're performing new commands. So, for example, if you had like pull request was approved, it will put this is approved, which you saw earlier, to true. So you can merge a pull request later on in a different command. And that's how events are applied against aggregates. Persisting events is done with repositories. Like the repository you saw earlier, you can retrieve pull requests, perform a command, and then this is also a trick by Freek, which he taught me. Like you can use a try finally method to let any exception that happens cascade, but still allow you to persist any events that were recorded against the aggregate. So what it basically does behind the scenes is like you open a pull request, but an exception was thrown, but you still wanted to like record a specific event. You record the events first, and then let the events cascade through the higher levels of your application, and you can react on them. Rebuilding the aggregates, if you saw the retrieve method here, what the repository basically does is it takes all of the events from the database or storage, whatever you're using, and it reapplies them to the aggregates before you can reuse them again. So it basically loops over the events and calls the apply method every single time. So the state in the aggregate is restored, and you can perform new commands against them. And how those events are stored really is called an event store. An event store can basically be anything. It can be a database table, a separate storage like Redis, whatever it is you really want to store the events in. In this particular example, I've shown you like how to create a database table real quick. And as you can see, it has basically a couple of columns. You have just an incremental ID. You have a specific ID for the events, which you can query against. You have a specific event type, the name of the event basically. You have the aggregate route ID, so you know against which, where the event belongs to which aggregate. You have a timestamp to record it, and you have the payload. And the payload is basically the event data that was inside the event. It's JSON serialized, really easy to see. Like I said, they're append read-only. Remember, the history never changes. You can't delete events, you can only add to them. You can live outside the main system. What we mean by that is that an event store really doesn't belong with all the other tables you're using to build your app. You can basically take that event store out, put it on a separate database connection, whatever. It doesn't really belong with all the other ones. Or you can keep them together, whatever you prefer. And it's the only part you cannot lose, and this is pretty cool as well. Like, because you're deriving all of the data and state from your events, you can basically drop all of your other tables, you can lose them, you can lose all your backups, doesn't matter, like everything really. And you can always rebuild that state from the events. As long as you have the events, you can always do whatever you want. That's pretty cool. So, how the events are handled in EventSauce itself, they're wrapped in what's called a domain message. And domain messages are really like small wrappers to pass the events around. They contain all of the data which we saw in the database table, like the event ID, the event payload, the timestamp, and the aggregate route ID. And that's the thing that's being serialized before it's stored, the event payload I meant. Now, you might wonder, like, okay, we've saw a lot about writing now. How can we do write operations? But how can we do read operations? Like, how do we display the data from those events in a human-readable way? And this is where message dispatching and consumers come in. So basically, what an aggregate route repository will do behind the scenes is it will take all of the events it has recorded and dispatch them throughout your system. And this is done with like a message dispatcher. It can be done asynchronous or synchronous. Synchronous is when you want to get things happen right away. So for example, you want to do updates on view tables, which will be displayed right after you redirect to your view. Or you can do asynchronous consumers as well. And this is like when you want to like send an email informing the maintainer that a new pull request has happened, a notification, something like that. So you basically have two consumers, like I said. You have what's called projections. Projections are the things that update state which can be discarded, rebuilt as many times as you want. And process managers, they listen to events and they basically perform one-time actions, things you can only do one time, like send an email. You don't want to resend emails every single time an event has been restored from an aggregate. But you do want to restore your state from your database, like how the pull request is viewed if that data gets lost, for example. That's where projections come in. So like I said, projections, like some examples could be database tables, PDFs, files, in the search indexes like Algolia, Elasticsearch, so stuff like that. Why are they useful? So like I said, they're super optimized. You can reconstitute them, like I said. You can discard them, rebuild them. You can have as much as you like. The example I showed way at the beginning was a projection that optimized for just specifically the view of a pull request as is. But you can basically have as many tables, as many projections as you can fairly want. And you're really optimizing for the view part. To give you a basic example of how this is done, this is a projection you build that pull request view that we talked about earlier. So when we get the message, the domain message, we retrieve the event from the message. We check which type it is, and based on the type, we're going to do certain actions. And this is where, for example, an elegant model comes back into play to create a record in the database, update its state, delete it, whatever. So rebuilding is unfortunately not baked into the EventSauce library. I'm maybe thinking of doing it in the extension I'm building. I'm currently working on a Laravel EventSauce extension, which is under the EventSauce organization as well. It's almost done. I hoped I could get it done by now, but unfortunately I didn't make it. After a conference, hopefully. So what I figured was because I know how the state is built up in the handle method, I might just add a different method to it to know how I can discard the state, delete the database table or whatever. So you can really easily destroy the data, rebuild it again from a backup, however you want. I might look into that. The different consumer we talked about earlier are process managers. And these are one-time actions. Like I said, email notifications, build triggering, stuff you only want to happen one single time. Why are they useful? Like I said, they're one-time actions. They handle non-user interactions, things that users can't do for you, like calls to send grids, stuff like that. And they're really a great way to offloading anything that you don't want that's really time-consuming, that you don't want a user to be worried about when they're doing a certain thing in your application. Everything that can be offloaded to the site. A process manager might look like this, like a pull request notifier. We get a new pull request was opened event, and we send an email to the maintainer informing him that a new pull request was opened. So other things that EventSauce can really do for you is can also generate commands and events from a YAML file. So commands and events are really very basic things which you might wasting your time on building. You can basically simply define what they are in a YAML file, and EventSauce can generate those classes for you, so you don't have to worry about them. In the package I'm going to build, there'll be a command to generate those for you, which is pretty cool. You can decorate messages with metadata, so you don't only ship the data you want from your events, but extra stuff which you want to add them. You can have versioning. Because what might sometimes happen is concurrency, people trying to do the same thing at the same time. So you might want to version your events. And it's basically an incremental ID in the database, so you don't have conflicts saving the same thing at the same time. You can use the testing tools. And this is a pretty cool way. It basically works in a behavior-driven design way, given, when, then. And it's just a really nice way to perform some testing against your aggregates. So I basically think this might be you after this talk. It was a lot. Sorry about that. But event sourcing is like a really cool thing. I took a really long time to wrap my head around it. It's not for every single scenario. Well, something you really need to know is that event sourcing really shines in situations where you have like a really rich domain, lots of business rules, lots of stakeholders at play, long-lived apps, like short-lived apps. I'm not really sure if event sourcing is the correct way for that. But like definitely give it a shot, give it a chance if you want to look into that. EventSauce Docs has a lot of reading material for it. It has like an architecture page which you can use to see how the library was built, the life cycle of like an event source application. Michiel Rook here has a really cool blog as well. A lot of like hardcore topics around event sourcing, how to handle GDPR requests, how to handle privacy, like encryption, stuff like that. It's pretty cool. Matthias Verhaas has a really cool blog about some more advanced topics as well, which you might want to check out. My buddy Freek already built some packages, of course. Like, what would you think? He built his own EventSauce extension already, which is pretty cool, which is pretty much done. He built his own pragmatic way of handling event sourcing itself, like with the event project package. It was getting really popular, really, so definitely give that a shot as well. Or you can wait until I finished my event source package, which should be like done in a couple of weeks at least. That's really it for me right now. Check out my blog, check my Twitter. I'm doing user groups in Belgium as well, in Ghent and Antwerp. If you're ever around in Belgium and want to give a talk, feel free to hit me up. I'm organizing a conference in Europe with Freek as well. Definitely check out that as well. We have a pretty cool lineup for you. Totally different conference than Laracon. Thanks, really. Hope you enjoyed. Thanks.